remember from the first time you passed through this, what this counter is counting, it's counting every time the beam goes from negative to positive. Every time the voltage going out of the detector changes sign, you can count it. Well, we have a clever way, using a second beam splitter, we have a clever way of getting two beams that come out, and these two beams have a coherent relationship such that when one is positive, the other is, when one is bright, the other is dark. When one is dark, the other is bright. So one of them is fluctuating bright, dark, bright, dark, bright, dark. The other is completely out of phase. Dark, bright, dark, bright, dark, bright. So now what we can do is this. We can feed two signals into the electronics. We can count, we can make a count every time. Suppose I'm going to give you signs. This is X, Y. Every time we go from negative, negative to negative, positive, count one. Every time we go from negative, positive to positive, positive, count one. Positive, 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 negative, count one. Positive, negative, 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 count one. So in other words, every time we go around from these quadrants, every time we cross an axis, we can count. But we know the direction that we're going in. So if we go in the opposite direction, we can count another way. The problem with the original setup was this: if the mirror was moving forward, it counted up. If the mirror was moving backwards, it still counted up. So I couldn't tell the difference between the mirror moving forward or backward. But now we can. We can, if you look at the camera, we can put the output from these two detectors into here, into the XY. And now what we have is this. We can see that the detectors are getting bright. They're completely out of phase, and there's a phase relationship between them. And if I switch this to quadrature count and reset it, watch what happens. When I go counterclockwise, the counter increases. When I go clockwise, the counter decreases. This is really useful, because now we can do all kinds of experiments. Also, remember this filter that stopped me from, remember this filter that said ignore all changes that happen less than a particular time? Well, we should turn that completely off. Now watch what happens when I tap this mirror. And look, I'm going through hundreds and hundreds of counts each way, and it always comes back to zero. Watch this. So we can see, if we put something in here, we can watch something push the mirror forward, pull it back, and then we can look at very small changes. This is called quadrature counting, and this is just a start of some amazing things we can do. What you could do is, you can look at a property called magnetostriction, very interesting. You can also set up different types of interferometers. This is the Michelson interferometer. There's a Sagnac interferometer, there's a Mach-Zehnder interferometer, there's all kinds of different configurations you can have. This will be completely broken down. The first thing you'll have to do is learn how to align your beam optics. That's actually section 0 in the manual. It's very clear, very easy to understand. You'll start off aligning your optics. I'll leave out everything else you'll need to complete a wide range of very exciting experiments, and you can decide what you want to do. Okay.